Good day everyone. The objective of this video is to show the practical application of bootstrapping statistics in estimating raw material cost. Let us say we have a raw material such as a coconut shell. These are already cut in half and the meat extracted. The cost of these shells are on a per piece basis, and we need to put in cost value on a per kilogram basis. We therefore need to estimate the range of the mean number of shells of coconuts that will make a kilo. First step, import the required libraries. Next is obtain data by weighing in how many half shells are there to make a kilo. So here it is. And third, divide these numbers into 2 to obtain number of pieces of shells per kilogram. So these are already number of pieces per kilogram, number of pieces of whole shells. Next is make the output of this script reproducible. So guys, you can reproduce the output of this script and create a bootstrap function that will generate sample with replacement from the original sample. In this case, the original sample is shells. Obtain the mean of the sample and return the same. This is a resample with replacement. Okay. Next, create an empty list. Run the function 1,000 times and store the statistics to the empty list. So shells is the original sample. And put it in the list. Put the mean of the replacement sample inside this list my mean. Now we need to plot the histogram of this mean. Okay, if we resample the sample 1,000 times, so these are the mean of the resampled. So the mean starts from 5.1 to the 5.7, so we can use this as to estimate the true population mean with confidence. So first, get the 95 confidence level of the range of mean statistic. Okay, 95% confidence level of that population mean, and sort it out from lowest to highest. So my mean, let's sort. Okay, it's already done. Next, since we have 1000 data points of mean statistics, the lower cutoff would be the 24th element and the higher cutoff is at 974th element. So that is 2.5%, or the probability of 0.025 is in the 25th element. And okay, since the Python list index starts at 0, Therefore, the 25th element's index is 24, and the 975th element's index is 974. The mean statistics index is the 499 elements, so we print all of them. So here is the result. So we are confident, 95% confidence, that the true population mean number of coconut shells per kilo is between 5.21 up to 5.57. And the median mean is at 5.38. So the last step, if per piece cost of the coconut shell is at 0.008, we can therefore multiply it by the median mean to get the median cost per kilogram. So the median cost, we are already confident that the median cost per kilogram of coconut shell is around $0.04 or 4 cents or approximately 5 cents per kilo. So that is how we use the Bootstrap statistics. Thank you for watching. See you in the next video. Bye.